All right, ladies and gentlemen, Mr. Mueller here. We're going to begin our next week of technical math. So this week we're going to look at the last section of Chapter 9, which would be cones and frustums of cones. Now, the thing is, we're not going to talk about frustums, okay? I'm going to take those out since, again, of the situation we have. So basically, we're just going to look at this last section. We're just going to look at cones, okay? So again, we're going to take out frustums of cones and just look at cones themselves. So these four objectives have been the same for this whole chapter. We're going to identify solid figures. Basically, again, not looking at frustums, but we're going to look at cones right here. And then we're going to look at lateral area and total surface area. We're going to look at volume, and then lastly look at some applications. Now, the thing is, a cone is very similar to a pyramid. The difference between well, first of all, the similarities is that a cone and a pyramid only have one base, and opposite that base is the apex, and the difference between that apex and the base, and I'll show it here, the distance between this apex and this base right here is the height. Now that's, again, similar. That's the same as with a pyramid. You have a base that's a square, it could be a rectangle, it could be a hexagon. You have an apex at the top, and perpendicular distance from that base to that apex is your height. Now, another similarity is that the distance from the outside of the base, the edge of the base, its perimeter, up to the apex is called the slant height. So that's also the same, and that's denoted by S. That's the same as a pyramid. The difference is between the two is that in a cone, the base has to be a circle, okay? In a pyramid, the base is not a circle. Like I said, it could be a triangle, it could be a square, a rectangle, pentagon, hexagon, so forth, octagon. So there's a lot of similarities. The main difference is of the circular base. So a cone is a pyramid-like solid figure with a circular base. The radius and diameter of the cone refer to its circular base. Okay? The altitude, which again is the height, h, is the perpendicular distance from the apex to the base. The slant height is the base to apex distance along the surface of the cone. Everything's different, and we even can use the same formulas, ladies and gentlemen, we did for a pyramid. So, let's start with the lateral area. And again, I put the net up here. And this right here would be the lateral area of the cone. Now, when we did pyramids, lateral area was equal to 1/2 times the perimeter of the base times the slant height. It's going to be exactly the same thing. If you take a look here, ladies and gentlemen, to find the area, the lateral area, this right here is the same as this perimeter of this base. That's where we come up with that, okay? Then you take it times the slant height, there's the slant height, and then times 1/2, okay? Now, these two formulas down here are on your formula sheet, and all they're doing, ladies and gentlemen, is substituting in the perimeter of the base, which is the circumference of the circle. So in other words, you're either going to look at that as 2 pi r or pi times diameter. So again, by substituting 2 pi r in for p there, or pi times diameter, you get these two formulas down here. So it doesn't matter to me which formula you use. Like I said, the two at the bottom are on your formula sheet. Okay? Now, to find total surface area, you just take the lateral area plus the area of the base. You take the lateral area, as we have here, plus the area of the base. Right there, just as you would with a pyramid. Pretty simple formula. And then finally, if you want to find volume, volume is equal to 1/3 area of the base times the height. Now again, what's area of the base? Since the base is a circle, remember area of a circle is pi r squared. And there's another formula given in your formula sheet if you want to use diameter. Basically, here are your volume formulas down here. So again, on your formula sheet, it gives you the lateral area formulas, it gives you the volume formulas. Now you're saying, again, what about total surface area? Just take your lateral area plus the area of your base. Even though it's not written on your formula sheet, it's understood to be that. Okay? So basically that's it for cones. Okay? Treat them like pyramids with circular bases. Now, we'll do an example here on the next slide and go through this to make sure you understand how to use those formulas.